6%, which showed that high, but at the same time, it showed the fact that conversions are very rapidly taking, and if such conversions are very rapidly taking, indicative or indicator of the fact of occupational shift in this area. So these are struggling with recovery and resistance. Risk pair new
That's why we need to optimize our parameter. So that's why I have calculated the effective weight of each parameter. Okay, using this formula, I will not go through the details because of time bound. So if you see the empirical weight here, elevation 27%, but here the mean weight is also more or less similar, 26%, but slope. Here empirical weight 19%, but mean weight is 30.65%. So so my recommendation is slope is more important parameter for flat susceptibility resolution for Vitruvius or similar kind of region, and also for distance from river. These are also more important parameter. But I have considered some parameter like topographic position index, then lithology. These are not the important parameter. We can remove this and we can remodel again for better modeling. So this is the effective weight for flat vulnerability parameter, 12 vulnerability parameter. Then similarly, you can see here the empirical weight for total population 23.5, but here the mean is less 18.17. But in case of LVLC, it was 15.3, but it has increased 21.56. But all are the important parameters because all are more than 3%. So we cannot remove any parameter. Now I have done the sensitivity analysis. I have done two sensitivity analysis, one single parameter sensitivity analysis and another map removal sensitivity analysis. There are single parameter sensitivity analysis for flood sensitivity parameter, how it is sensible with the flood, and here the sensitivity parameter for the flood vulnerability, and this is the map removal sensitivity parameter. That's when I have considered the 2F parameter for flood vulnerability mapping. Now I remove one parameter one by one. First I remove elevation, then I prepare the model, then again I remove slope, then again prepare the model, then I check this. I have prepared this statistics, which is most sensible. Okay, when we remove elevation, very low increase by 28.57%, and also very high increase. So we cannot remove this parameter. Also slope, also TWI. So we cannot remove this parameter, but when we remove TPI, is more or less similar, very low increase by only 0.05 and very high decrease by minus 0.70. So we should remove this parameter, and we can also remove other parameter like, yeah, we can only remove TPI only because here the sensitivity is very less. Okay. So if we remove this parameter, then definitely we'll get a better result. So this is the similar analysis for flat vulnerability. This was flat susceptibility and this was the flat vulnerability. All are important parameter. You can see we cannot remove any parameter because all parameters are sensible for this flat vulnerability mapping. Now coming to the model validation. So after preparing this model, we need to use the classification technique in the NHGIS platform. So there are many techniques like natural break, geometric quantile, and equal interval. And we have found that natural break or geometric method is more accurate over the quantile and equal interval. And we have finally considered the natural break method for preparing this map. And we have found accuracies 72%. It is okay for us, but definitely if we remove this parameter, basically TPI, then definitely we will get a better result. And we also calculate the error metric like mean absolute error, mean MSC, then RMSC, and here ME 0.15, MSC 0.16, RMSC 0.21. So all are very less. So our result is too robust, we can say. Coming to the major findings. So, in the present condition, we have found that only 27% of Uttar Pradesh district facing moderate flood risks, 15.61 as high, 4.59 is very high. But when you consider the SSP 245 scenario, it increased 19.65 extended as very high. So, definitely, we need to think about it. We need to prepare ourselves. And if you see the geographical distribution, high and very high risk zone are concentrated. These blocks basically Gopal Focus 2, Raigons, Kaundiki, and other blocks. And basically, we need to focus particular area like those area, low elevated area, high tropical wetness index, then low NDV area and high drainage density area. We need to focus those area. Now coming to my last slide, how we can contribute with the pillar of leadership power. So our study directly linked to the various pillar of leadership power. First pillar of leadership power, sustainable environment and climate resilience. So definitely the flood modeling in the previous lectures as told about we need to prepare the vulnerability and risk mapping, then we can mitigate it. So definitely our flood modeling help the mitigate the disaster, enhance the resilience and guide to for take the adaptive strategies. Then technology advancement and digital empowerment. Like now we can use geospatial innovation like not only MCDN model, you can use machine learning, deep learning, AI, technology-driven technique for the solution of disaster risk reduction. Then infrastructure development and urban-rural integration. If we can identify the risk-prone area, then this support the civil planning, infrastructure development. Especially, we need to focus very high vulnerable areas. So then, good governance, participatory decision making, definitely validation of models provide a decision support tool for policymakers, contributing to transparent and data-based disaster governance. Then social equity and inclusion. Actually, this pillar of Bishop Health is important, and in our research, protecting life and livelihood in disaster-prone areas help reduce the vulnerability among socio-economically disadvantaged population. If you see the previous flood in North Bengal, so we found that many causalities, and that's happened basically in disadvantaged groups of people. And economic growth and risk-informed development. DRR reduce economic losses from disaster, ensuring more sustainable and stable growth. So this way we can contribute the pillar of Vishit using our geospatial science. Thank you, organizer, for giving me this opportunity.
Thank you very much. Dr. Dash has presented a kind of methodological overview in front of us. It was a bit technical, although, but in terms of presenting a kind of map, understanding the reality, it was quite essential in this field, in the field of disaster management, geography, and environmental sciences. So without wasting time, I would like to request both the moderators of this session to kindly take over the charge and call the name of the presenters, online presenters, one by one. Uh, this is my, request. It is over to you, Dr. Darshan Shah.
Okay, yeah, Devorshi, thank you for charging over the session for the further prosecution. We have, suppose, so many presenters here, and if you, with the permission of Dr. Dash and other presenters here, if I request our respected session in charge, I think my direct student Sanjay is there. So Sanjay, kindly, if you read out the presenter's name one after another, it will be helpful for us.
I think, sir, one list I have already sent to Dr. Joyanto Dash.
Okay,
So Dr.
Johnson, if
Dash
you,
can manage, I
Yeah.
think.
Okay,
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 Johnson,
okay.
thank you, thank you.
I have this list.
Okay, okay.
Uh, Sir, we have 9 presenters in this session. First presenter, Dr. Gargi Sengupta. Then, yeah, Gargi
Yes,
Madam
sir.
is there. Then Shantanu Mandol. Then Shakia Sinha. Shomojit Haldar. Then Gopal Roy. Then Prakash Roy. Then Sushmita Mandol. Soumyapatik Datto. Then Dr. Sanjukta Rao. So we have
Yes,
9
sir.
presenters. So I think, sir, if we provide 8 minutes for the presentation and 2 minutes for discussion, then we'll need 90 minutes. That's been 1.5 hours.
It's
Is
fine,
it
it's
okay,
fine.
sir?
It's fine, it's nice.
So our first presenter is Dr. Gargi Sengupta, and title of presentation is Climate Induced displacement and emerging humanitarian crisis in reference to North Bengal, India. Madam, can you share? Yes. Yes. So, Madam, 8 minutes for the presentation and 2 minutes for the discussion.
Sir, is my screen is visible?
Yes, it is
Yes.
visible.
So the title of my presentation is Climate-Induced Displacement and Emerging Humanitarian Crisis in reference to North Bengal, India. Uh, just a second, sir. Maybe there is a problem. Just a moment, sir. Sir, maybe I'm facing some difficulty in slide changing. Just give me a moment, sir. My slide is visible to everyone?
Yes,
It
madam,
is
your slide.
visible.
Okay.
Go with the slideshow mode.
Okay, sir. So, good afternoon, everyone. The title of my paper is Climate Induced Displacement and Emerging Humanitarian Crisis in reference to North Bengal, India. One of the greatest challenges of present time, nationally and globally, is the unpredictable and peculiar nature of climate change. Climate change is often referred as the natural, gradual, long term change in weather and temperature. The primary causes behind natural climate changes are solar variation, change in Earth's orbit, or volcanic activities. However, the important point is any shift in the climate through these factors are time taking. That means thousands and millions of years are required, which gives sufficient amount of time to both ecosystem and human beings to adapt and accommodate with these changes. Contrast to this, the human causes behind climate change are industrial produce, burning of fossil fuels, urbanization, deforestation, etc. All these result into the release of greenhouse gases and trapping of heat in the atmosphere. The concern is the rate of climate shift due to the human causes are speedy and haphazard, chaotic and extreme in nature. This human cause centric climate change is known as anthropogenic climate change, which results into global warming, that is increase in earth's temperature due to concentration of greenhouse gases, which would further results into melting of glaciers, ice sheets and rising of sea level, which would immediately affect the coastal areas and gradually the non-coastal areas. This rising of temperature would alter the climate pattern so that one can see a drastic change, flood, and drought at the same time. Thus, the interplay between the human activities and the atmospheric composition is complex and associated with multiple threats. This creates an interconnection between climate crisis and human displacement, referred as climate induced displacement. Human mobility is an age old practice of human society. This movement is either voluntary and non voluntary. In case of a voluntary movement, the choice is associated with the decision of a person. But in the case of a non voluntary movement, people are being forced to displace from their place due to some major reasons like war, conflict, development projects, natural disasters, and others. In all these cases, it is difficult to tackle and control the immediate effect. Therefore, displacement is the only option, not by choice but out of compulsion. Such type of displacement is non-voluntary decision where displacement-centric risk, challenges and hardships are huge and have a pinching effect. In non-voluntary climate-induced displacement, the people decision is rapid, instant, urgent due to the severe effect of the disaster in the form of heavy rainfall, flood, earthquake, cyclone, etc. In this situation, leaving the habitual place becomes the optimal choice. Though climate induced displacement is not a new concept, yet its visibility and severity is increasing day by day. The reality is, damages related to the climate crisis are often calculated on financial terms and loss of resources. But the other side of the story is equally important, that is, the human cost associated with it. Climate induced displacement have become one of the main reasons behind internal displacement, and it is associated with adversities and known unknown challenges. It is affecting the life of the people socially, economically, psychologically. The consequences are huge in the form of a human pain, both in the decision of displacement and also after the displacement. Apparently, it seems to avoid the climatic disaster effect, displacement or resettlement is a better option. But the harsh reality is such type of displacement is an expansion of vulnerability in terms of lack of security, opportunity, discriminatory treatment, and powerlessness. Coastal areas, hilly region, low-lying areas are primary sufferers of this type of climatic shock. Now, let me move to my research area, North Bengal, India. North Bengal refers to the northern side of West Bengal, comprises of 8 districts: Alipurduar, Coach Bihar, Darjeeling, Jalpaiguri, Kalimpong, Dakhin Dinajpur, Uttar Dinajpur, and Malda. This particular region has both geographic and strategic interest for India, as the region is sharing the geographical boundaries with South Asian neighboring countries Bhutan, Nepal, and Bangladesh, interstate borders with Bihar, Assam, Sikkim, and the Shiliguri corridor, known as the Chicken Snake, is the gateway to connect with the northeastern states of India. North Bengal is one of the attractive tourist spot because of the connection between the different landscape, the hilly terrain of Darjeeling and the Duars Plain. Darjeeling, famous for the elevated mountain view and tea gardens, and Duars Plain is well known for forest, river, wildlife. Due to heavy rainfall, this particular place has transformed into a place of disturbance and humanitarian crisis. Now, let us see what are the reasons or causes behind climate change in North Bengal. The geographical locations like hilly terrain, river, forest, meteorological factors, monsoon, wind, the orographic effect of Himalaya, and the anthropogenic reasons like urbanization, unregulated construction, deforestation, river mining, dumping of illegal debris, commercial activities, illegal sand and stone extraction, expansion of NH10. These are the factors which is making the climate erratic in the North Bengal region. From the past few years, 2022 onwards, we can see many a times the districts of North Bengals are facing substantial impact of climate change. Jalpaiguri, Darjeeling, Alipurduar, Coach Bihar, Malda are the vulnerable districts as they are facing the adverse effect regularly. The consequences of calamities are damage of land, road, bridges, internal migration and displacement, rise of waterborne diseases, etc. All these problems resulted into financial infrastructural loss, disturbs the strategic significance, and above everything, humanitarian crisis. Now, the climate change not only affects the entire population, it primarily affects the economically poor group who all are working on daily basis for earning their livelihood, and their settlement is also informal in nature. Being a tourist spot, multiple informal job opportunities are present here, but these sectors all are suffering because of the recurrent episode of climatic disasters. All these sectors are suffering to a great extent, resulted into expansion of human vulnerability, specifically for the people who are at the margin. Due to flash flood and all, their bridges, houses, roads, everything has suffered a great loss. If we see this particular site, the relocation site, it is also something important to the concern. Usually, the government and the allied agencies provide immediate relief to the sufferer, but the vulnerability continues. Here, my point is providing relief after disaster is only procedural solution. Rather, the need of the hour is to provide substantial solution and opportunities so that repetition of such episodes can be avoided, and there is also a need to develop resilience and power of the society. Thus, to conclude, Climate change has a compound effect upon the human life in terms of weather alteration, increasing tendency of migration and displacement, and above all, vulnerability. In this context, the non economic humanitarian loss is beyond imagination and calculation. Both government and people's active participation is required to arrest the escalation of anthropogenic causes of climate change so that we can address the present and the future challenges. Awareness, preparedness, adaptation, mitigation should be present at local, national, and global level. Though we cannot completely reverse the previous human mistakes, but through an holistic approach, we can develop a collaborative local, national, global, and environmental governance program so that together we can protect and preserve the environment and human society. Thank you.
Thank you, Gayatri Madam, for your nice presentation. So now, Snashi sir,
Yes, yes. I don't have
please.
any question. It was observation that in recent work,
Hmm.
many of the areas of North Bengal
Yes, sir.
lost a big property loss. So in the future work, madam, if you consider some database generation and some database related work, it will be most helpful for us. Thank
Surely,
you.
sir. Thank you.
Yes, thank you, madam, for your nice presentation. And this is my also observation. You should incorporate some field data for your future study, not only for the displacement, climate displacement. I think climate diffuse is one of the important factors here. So you should also incorporate the climate diffuse in your study.
Okay, sir. Surely.
Okay. So our next presenter, I guess Shantanu Mandol. There
Yes,
are
sir.
two
Yes,
names
sir.
there,
Present.
Shantanu
Yes, sir.
Mandol and Abida Dattodoy.
Yes,
Yes,
sir. I am.
please, yeah, please try to conclude within 8 minutes. Okay. If possible, then turn on your video also.
Am I visible, sir?
Yeah, you are visible. You are not visible. Your PPT is visible now. Okay, Shantanu.
Oh, okay, sir.
Please start your presentation.
Okay, sir. Good afternoon, sir, and everyone. I am Santanu Mandal, research scholar of Bakur University under Department of Geography. Uh, my presented topic is forest biomass assessment, a estimation of salt through the non-destructive field approach and evidences for branches division of Bankura. This is short introduction. Forests play a key role in mitigating climate change and capturing and storing atmospheric carbon. The amount of carbon they can store depend on their biomass, which varies with soil and climatic condition. In the Bankura district Panchayat division, natural salt forest act as a major carbon sink and extremely important for long-term ecological stability. In this study, we used to measure or estimate a non-destructive field-based method for biomass estimation. This is our study area. Mainly sal plantation, natural sal forest are taken for study. Almost 81% of the forest area are under the sal forest of this division, and these are the objectives of my study. The primary objective of the study is to assess the biomass stock of native and natural forest of in this region. To support this primary objective, the present study framed the following objective: to assess the above and below ground biomass of natural forest of the study area, to estimate the total biomass of the forest, to find the significant element of tree allometry in the region. Both kind of the data are used for primary data and secondary data. Primary data was collected from the field using sample coordinate by measuring tree height, circumference, and counted the total number of tree as per plot for biomass stock estimation. This source ensured the accurate and reliable data of our study. This is the methodological framework. methodological flowchart or methodological framework. First of all, this we began to collect the topographical map and from Survey of India and forest map from Forest Department. These map were georeferenced and digitized to delineate forest patches. And the next 5 into 5 kilometer grid was generated over the study area, and grid containing forest patches are identified and serially numbered. And then it is verified with Google Earth map and also field data. Next, we extracted the forest data, dense forest, fairly dense forest, and open forest using the random sampling and represented grids were selected. When each selected grid random sampling point was generated using QGIS software and modified according to accessibility. For field data collection, 10 into 10 meter quadrant were established at random point. A pilot survey was conducted first to determine DBH, and based on this DBH, the optimal sample size was calculated using Choco's formula, and status-wise sampling plots are determined by the Cochrane formula. Next, in each quadrant, three biometric parameters like DBH, tree height, and tree density are recorded following a non-destructive method, and GPS-based observations ensure the accuracy of geolocation of sampling plot. Uh, after data collection, the species-specific allometric model was applied to estimate the above ground biomass, and below ground biomass was estimated through the root shoot ratio, and finally total biomass was calculated by aggregating the above ground biomass and below ground biomass. And these are the map shows the sampling plots and pilot survey plots, and these are the details methodology, and this also same for AGB was calculated by using wood volume into wood density, and volume was calculated through the following FSI equation, and above and below ground biomass also calculated from this equation. These photographs are taken during the pilot survey and final survey. Result and discussion. This slide illustrates the distribution of biomass. Sorry, sir. A pilot survey was carried out across three representative sample plots covering fairly dense and open forest data to recorded tree height measurement. Based on the rebase data, the mean standard deviation and coefficient of variation are computed and applied to Choco's formula, and for determining the optimum sample size at a 10% standard error level, and the analysis found the optimum sample size is 17 plot for systematic biomass assessment in Panchet Forest Division. And this table shows the details of data. This slide illustrates the distribution of biomass in the dense sal forest. We observe the noticeable variation across the sampling forest, and the highest biomass was recorded in Asna Sundarpur, and the lowest in Chowk Nikunjapur. And if we look into the standard deviation and mean, and then we then we found the variability below ground biomass and total biomass. This diagram shows the relationship between different parameter of allometric models like tree height and DBH, and tree height and with biomass, and tree height DBH with biomass, and all are found the positive correlation. Their relation is very strong in DBH and biomass. DBH and biomass. DBH more practical and reliable parameter for biomass estimation in dense sal forest condition. This distribution show the biomass of fairly dense sal forest. And the results show the high variability across the sampling point. Highest above ground biomass was found in Basudebpur, and lowest found near another plot of near Basudebpur. And the mean biomass per tree in this data is 283.51 kg with the high standard deviation 404.9 kg and this result highlight the strong structural heterogeneity and uneven biomass distribution with fairly dense cells stands or strata. Next. Uh, and this correlation also found the positive correlation, but the overall DBH remain the best predictor for biomass estimation and in fairly dense cell strata. This diagram show the distribution of distribution of biomass in open sal forest, and only two plots are selected for biomass estimation, and one is Jamdoba and Bhagnagar. Second is more. The average tree biomass in this datum was 202.09 kg with a standard deviation of 119.36 kg, including the comparatively lower biomass accumulating in moderate variability relative to denser sal forest category. This diagram shows the relationship among the DBH, tree height, and biomass. This relationship found the positive and similar to the previous relationship. Biomass and DBH found the very strong positive relationship in this category. This diagram, this map show the spatial distribution of biomass on sampling pots, and the table shows the biomass ton per hectare in over the total forest area. Dense forest found the second highest biomass stock in ton per hectare, 225.41, and the highest was found the forest and 340.22, and open cell forest is the lowest. And these tables show the
Shantanu, please
total.
wind up. This one.
Sir.
Please wind up. Please go to conclusion section. Just conclude it.
Okay, sir. These are the key findings. Biomass varied noticeably both across the different plot or a different plot within individual plots. A high to very high positive correlation was observed between the tree height and DBH, and in sal forest, and biomass exhibited a positive relationship with both tree height and DBH. And the DBH biomass relationship was very strong across all states. The tree height and biomass relationship was strong for all strata except the fairly dense sal forest. However, the fairly dense sal stratum recorded the highest biomass stock in among all. Interestingly, in the studies, the per hectare biomass productivity of fairly dense sal forest was higher than that of dense sal forest, where under the typical ecological conditions, dense sal forest generally store more biomass. The total biomass stock of the natural sal forest in the division was estimated 7.42 megaton. These are the short conclusion, and these are the reference of this study. Thank you, sir.
Thank you, Shantanu, for your nice presentation. Snehasi sir, please, your objection, please.